I'm reading this archaeology textbook. It's about to get into dating and how archaeological findings are dated to see what time period they're from. And this is something I've always been curious about, so I'm kind of excited. Alright. While archaeology remains at heart a humanity or social science, the study of humans and human societies, it also draws on a range of other disciplines, including the sciences, physics, chemistry, biology, botany, geography, and geology are employed for the discovery and analysis of excavated materials, to understand prehistoric lifeways, and to reconstruct key features of the environments in which previous human societies lived. Okay, so archaeology is something of a cocktail of many different sciences put together, and also it definitely does have its own unique characteristics. So, archaeologists today make extensive use of computers both to record material in the field and for such statistical and analytical techniques as GIS and computer modeling. I don't know what GIS is. Most archaeologists will also be familiar with human and animal anatomy, and with the technologies used to make the ancient artifacts that they study. Okay, yeah. The dependence on such a wide range of other disciplines is a key feature of the archaeological approach. Alright, so that makes sense. I never considered the fact that archaeologists would have to be familiar with anatomy, and would have had to have taken anatomy classes in college or high school, probably college. That's interesting. I never thought about that. And then it makes sense, though, because when you're analyzing fossils, you need to know about the human body. When you're analyzing animal fossils, or at least if you stumble upon an animal fossil, because I don't know if an archaeologist would be the one picking apart an animal fossil. That would be a paleontologist, if I'm not mistaken. But I can see it being very possible that you can be both at the same time, because if you're digging, you're digging. Alright, okay. Dating. The construction of a reliable time frame has been an essential ingredient in building a secure knowledge of the human past. For more than a century, archaeologists have borrowed three basic principles from geology to provide backbones for time frames around the world. Interesting. The first of these is the principle of superposition, which states that if a sequence of sediments is unmixed and undisturbed, the oldest layers will be at the bottom. These sedimentary layers are called strata, which together form stratigraphy. Okay. So, like, the study, I was reading about this in a paleontology book. It's like the study of rock layers. Although this relationship seems simple and even self-evident, its logic is fundamental in terms of positioning sedimentary layers to help build chronologies in all parts of the world. Interesting. So it's like you try to figure out how old something is just simply by noting the layer of rock where you found it. And that seems very simple, but it does seem like it makes a lot of sense. The only pitfall I could see there is that if you stumble upon something that was once discovered before, like something that's been discovered more than one time, then it could work its way up through the strata as it continues being discovered. Of course, this would require millions and millions and millions of years to take place. More years than humans have been alive. But I could see it happening, but it's not really I don't know if it's necessarily a problem. And also, another problem I can see is that it might not be incredibly precise. Not saying it wouldn't be accurate, but it wouldn't be precise. It wouldn't, like, you could say to yourself, okay, this rock that I found dates back to between 10,000 BC and 20,000 BC, but you wouldn't be able to find a relic from, I don't know, 200 BC and say it was from the Peloponnesian War. I don't think the Peloponnesian War happened in 200 BC, but you know what I mean. And also, there's also the problem of people burying shit under the ground. So I don't know. Maybe I'm missing some shit. So let's just keep reading, because I just yapped for a long ass time. Okay. Related to superposition is a second principle, the principle of association, which states that materials found close together tend to date roughly the same period. Very different animals thrived in the past, for example, woolly mammoths, but we can deduce that any human fossil or artifact found in the same layer as a fossil of that extinct animal must be of similar age. Okay. I'm trying to wrap my head around that because I'm a little sleepy. Any human fossil or artifact found in the same layer as a fossil of that extinct animal must be of similar age. Yeah, I mean, that makes sense. Again, there's like the topic of digging and what that might do to tinker with that, but that's probably not a huge problem. The third principle related to the second is the principle of strata identified by fossils / artifacts. As already noted, because different animals existed in the past, when fossils of certain species occur together, the age of those deposits can be established. The same principle is useful in archaeology because different groups in the past used unique kinds of artifacts, which when they occur together provide a rough estimate of age. Okay, so if you find like a human fossil right next to a woolly mammoth fossil, then, and you already have reason to believe that they existed at the same time, it would make sense. It would make the time period more certain, if that makes sense. It would make the degree of confidence that those two things are a certain age more it would make it higher. I'm sorry, bro. I'm not this fucking dumb all the time. I'm just tired. I'm going to sleep in like 30 minutes. I probably shouldn't be reading a fucking archaeology textbook. Right now, these three principles provide the foundation of all archaeological dating techniques because practitioners in these fields use them to evaluate the context in which samples for absolute dates are obtained. With these principles in mind, other methods may be used to assign absolute numerical ages for deposits and to the materials they contain. Alright, this brings us to radiocarbon dating. I've always wondered what the fuck that meant. always wondered what this was. In the late 1940s, a Chicago scientist, Willard Libby, developed the first absolute dating technique, radiocarbon dating, also known as carbon-14 or C14 dating. Oh, you know what? Quick sidetrack. I was reading a biology textbook like last week. I have a YouTube video up about it, and it was talking about carbon and how the atomic number for carbon is 12, but carbon can have the atomic mass for carbon is like 12 because it has 12 protons and 12 neutrons, or at least it has 12 neutrons, and there's more rare versions of carbon called they're isotopes of carbon that have uneven protons and neutrons, and there's carbon-13 and carbon-14, I think, and carbon-14 is way more rare than carbon-12 or carbon-13. Anyway, I wonder if that's what this relates to. The method is widely applicable to organic archaeological materials, for example, charcoal, bone, and shell. The result, radiocarbon revolution, brought about many surprises, not least of which was that the European later prehistoric period was twice as long as had previously been assumed. Whoa. And that the origins of agriculture occurred much earlier than originally thought. So radiocarbon dating brought us to that conclusion. What the fuck? That's insane. What the fuck? Whoa. That's really cool. Okay. I still want to know what it is, though. Radiocarbon dating depends on the predictable decay to nitrogen of the unstable isotope carbon-14. Okay. So it is an isotope. Radiocarbon dating. I still don't know if I forget what this 14 means. I think it's the mass number, but I don't remember what the mass number actually means. I don't think it means it has 14 protons. I don't think that's what it means, because if it had 14 protons, it would be a different element, because you classify the elements based on how many protons they have, if I'm not mistaken. Am I mistaken? Can there be comments made in the comments section, please, if I am mistaken? Because I thought that the number, not usually, but sometimes when you're listing an element, you would put this 14 right here, and then you would put, and that would be the number of protons, and then the number at the bottom would be the mass number, the atomic mass number. And I kind of forget what the atomic mass number means. I'm not gonna lie. Oh, but maybe the atomic mass number is at the top. And maybe okay, we're gonna have to look this up now. No, fuck it. I don't know if I have any unnecessary shit on my browser that I can't let you see, but I'm pretty sure you can't see my browser right now. Fuck it, man, I don't care. Radiocarbon dating remains the most important absolute dating method for the period after 40,000 years ago. Okay. So the most recent 40,000 years, is that what that means? It's most important for that time, or is it most important when it says after 40,000 years ago? Does that mean like when you go back in time, like past that 40,000 years, like before that 40,000 years ago? That's a little confusing wording. I'm guessing it means from 40,000 years ago and beyond, and forward in time. Whatever. Carbon is present in all living things, entering plants through the process of photosynthesis, and then into animals which eat the plants, and up through the food chain. Carbon occurs in 3 isotopes of similar chemical properties, each with a different atomic weight. Okay, so it is the atomic weight that it is, so I got that wrong. But it is an isotope, which I got right, so 50%, that is still an F. 12C, 13C, and 14C. Of these, 12C and 13C are stable, whereas 14C is unstable, and it is radioactive. Oh, shit. I knew that. Okay, it takes about 5,730 years for half the amount of 14C in a sample to decay, a period known as its half-life. As the ratio of 14C to the stable isotopes 12C and 13C is known, the original amount of 14C in the sample at death can be estimated. Oh shit. That's really fucking clever. Okay. Oh shit. That's really interesting. Okay. So since life uses carbon, the carbon is present in all life, and it seems that there's a very specific ratio between the 3 isotopes, or between standard carbon, 12C, and its 2 isotopes, 13C and 14C, it seems there's a ratio, a documented, predictable ratio between those 3. So, since 14C is radioactive and has a half-life, and I'm guessing 12 and 13 don't have a half-life because they're not radioactive, they're not unstable, then when you look at how much 14C is there compared to how much 12 and 13, and you do them, and then it's a mathematical equation. Then it's just math. What the fuck? Modern methods of detecting surviving amounts of 14C in samples, which include accelerator mass spectrometers. AMS dating. What the fuck? Modern methods of detecting surviving amounts of 14C in samples, which include accelerator mass spectrometers. I don't know what the fuck that is, dude. Are very accurate and a precise estimate of the amount of 14C that has decayed in a sample since that organism's death can be turned into a radiocarbon date using the half-life. I don't know what the fucking accelerator mass spectrometer is. Accelerator mass spectrometer. That's a fucking brain fryer. Alright, so accelerator. I wonder if that has to do with particle accelerators. Mass spectrometer. So meter means like measure. So what does spectro mean? I don't know. Like specter? Like ghost? That's... I don't know, dude. Speck? Like tiny? Speck meaning tiny? Like a little speck? Maybe. I don't know. The major assumption required by radiocarbon dating, however, is that the production of 14C in the upper atmosphere has remained constant. Comparisons of samples dated by the radiocarbon method and by other independent methods, e.g. dendrochronology, don't know what that is, have demonstrated that this is not the case. Huh. Oh, interesting. The production of atmospheric 14C has fluctuated over past millennia, being sometimes lower and sometimes higher than today. Radiocarbon dates are therefore calibrated against other dating methods to provide a true calendar date from the apparent radiocarbon age. That's really smart. That's really fucking smart, because oh my god, that's really interesting that scientists were able to check carbon dating against other dating methods that interesting. They compared it against other dating methods and found that it falls short. So it's kind of like checks and balances between the dating methods. All right, well, that's the video. I have to go. It was a short one, kind of. But we just learned what radiocarbon dating is. And every single time that I read some shit on the internet, and it's like, oh, scientists have discovered a new fucking snail penis that they didn't know about before, and they used radiocarbon dating to point it back to 8 billion years ago. Some shit like that. I never knew what that even meant. And that's really cool. If you go back and and look at my biology video, I might put it in the end screen. It's like, the video is called like Learning Biology. It's basically just chemistry. It goes into the different isotopes of carbon and how they're necessary for life. That's really interesting. How it circled back in this fucking completely different archaeology textbook. That's so cool. Yeah, it's really good. That's really fucking dope. So I'll come back to this at some point. I'm going to come back to this textbook and we'll read about potassium argon dating and luminescence dating. I wonder what that is. And we'll read into other chapters and learn more about archaeology together. And until then, I will probably not see you. You might see me, and I might see you and not even know it. Got playlists. If you want to look at more archaeology videos, I have a playlist somewhere. I'll put it up here. My name is Luke. This is Castles in the Air. This channel is called Castles in the Air because I have a lot of different lofty goals that I have not much of an expectation of actually accomplishing. So it's like building a bunch of castles in the sky. One of these goals is to be an archaeologist. Another is to be a musician. Another is to read a lot of books. I don't fucking know. There's a lot of them. There's a fuck ton. Can't list them all. And you know what? It's not that I don't think that I'm going to get there. It's that I do view it as a very tall task. It's very difficult to get there. Do I not think I'll get there? I don't know. Who knows? Okay, I'm done talking. Goodbye.